Guys, like I've been saying that throughout this time around, I'll be busy treating paper one since we are preparing for, of course, our trial examination as well as our final examination. So just go through with me so that we assist each other in the process. There's a question here, and then on this video I'm treating question 3, which is based on vertical projectile. I'm not going to say much. I'm just going to shoot straight to the example so that I do more examples. The more I do more examples which are different, it's the more you will be assisted. So there's a question here. It's saying in the diagram below, point A, there it's point A on the diagram. It's the top, at the top of the building. So we are told that point A is at the top of a building. There's a full stop. Point B, there it's point B. We are told that it's exactly halfway between point A and the ground. So basically, it means now if we are to find the height of our building, this is gonna be the height from A to B. Of course, we can say plus the height from B to what? B to the ground. And then now, we know that the height from A to B, we are told that now this one it's gonna be twice or halfway between the point A and the what and the ground. Simple like that. And then now the first question it's saying to us, define the term free fall. So then now as a learner, you know that there's a term free fall and the term projectile. So when talking of free fall, we basically talking of the what? Of the motion. Now when talking of projectile, we're basically referring to the object in motion. So when talking of free fall, it's the motion of an object under the influence of the what? Of the gravitational force only. Meaning all objects that are in free fall, they only experiences one force, which is the what? The force of gravity. Then now they say a ball of mass 0.4 kg. So we are given the mass of the ball, which is 0.4 kg. It's dropped. So the term drop, it's basically giving us our initial velocity of what? Of 0 meters per second from point A, then it passes point B after 1 second. So it passes point B after 1 second. Then now the next question, which is question number 2, it's saying to us, calculate the height of point A above the ground. So the first thing that we will do together, it's us analyzing everything that is given. The first thing that we know it's given, we are on the second question. Then now we are focusing on point A. So on point A, we know the initial velocity at 0 meters per second that we know. Basically, they are looking for the height from A to the ground. So my point of focus on answering this one, I'll start by focusing on point A and what? And B. So the next thing that I know between point A and B, it's delta T, of which my delta T is 1 second that is given on the statement. Then again, we know that we've got what? We've got the gravitational force, which is equivalent to 9.8 meters per what? Meters per second squared. And then now we can find the height. The height is gonna be from A to what? To B. Then the height is what? It's unknown. Then after collecting your data, make it a point that you associate the sign. What do I mean? You choose the what? The correct direction. So if you associate or you allocate upwards to be positive, then it means your downwards must be what? Must be negative. So allow me to say upwards as positive. So I'm falling for upwards as positive, meaning everything below my starting point, it's gonna be what? It's gonna gonna be negative. So then now, because now the gravitational acceleration is always acting downward. So now since I said upwards is positive, it means this one must be negative because it's below my starting point. And again, the calculated height, we're expecting it to be negative because still again it's below what? It's below the starting point. Between what? Between A and B. So from after doing this, we're gonna choose the correct equation. As we choose our correct equation, we can say delta y is equals to VI delta t plus 1g delta t squared. That's our correct equation. Then our correct substitution, it's gonna be 0 multiplied by 1 plus 1 over 2. Then our g, it's negative 9,8. Then our delta t, it's 1 squared. So we can see that a half multiplied by negative 9,8 multiplied by 1 squared will give us negative 9,4 meters. Like I said, we set upwards as what? As positive. So we know that from A to B, then our height is what? 4,9 meters. So then now to find, of course, to find the height of A above the ground. So we'll be saying 4,9 multiplied by 2, of which this one will give us what? 9,8 what? 9,8 meters. So we're done with question number 2. Let's continue to attempt question number 3 of the question. They are saying here, when the ball strikes the ground, it is in contact with the ground for what? For 0,2 seconds, and then bounces vertically upward. So we are told that after it is dropped, it then strikes the ground. It was in contact with the ground for 0,2 seconds. After being in contact, it then bounces up. It bounces up vertically upwards, reaching a maximum height at point B. So it bounces off, reaching a maximum height at point B. So we know that the height at point B is what? It's 4,9 meters. And then now the next question, which is question number 3, saying to us for 3 marks, calculate the magnitude of the velocity of the ball when it strikes the what? When it strikes the ground. So it's simple again to attempt this one. Mind you, we now know the height of the what? The height of the building. So again, on answering question number 3, we're still saying upwards as what? Upwards as positive. So we are focusing on point A and the what? And the ground. So we will apply this one. Our V finally squared, it's gonna be our VI squared plus 2G delta Y. And then after that, the final velocity, this is what we are looking for. Initially, it is dropped plus 2 into negative 9,8. Then now the height of the building, it's gonna be negative because it's below the starting point. So we punch our calculator together without wasting any time. 19,6 multiplied by 9,8. So in this case, we are having 192,08. Mind you, it's final velocity squared. So we square both sides so that we can find our final velocity. So if we introduce our square root here, then our answer will be what? Our answer will be plus or minus 13,859 meters per second. And then from there, so now we know that we are looking for the final velocity, and we are expecting our final velocity to be negative, since we say upwards as positive. So finally, our answer, it's gonna be 13,859 meters per second, where downwards, which is the what? Which is the direction. So that's our 3 marks. Then now, the next question, which is question number 4, they're saying to us, we must calculate the magnitude of the average net force exerted on the ball while it is in contact with the what? With the ground. So in attempting this question, I want us basically to draw a small scenario or diagram here. Mind you, that is the object from the height of the building, which is 9,8 meters, meaning it's from point A to the what? To the ground. Then it bounces off, reaching a maximum height at what? At B. So we know that this height now, it's gonna be what? 4,9 meters. So they are looking for the force exerted by the ground on the ball while in contact. So we're gonna focus on the ground and the maximum point in finding the velocity with which the ball leaves the what? Leaves the ground. So there we go. We're still saying for question number 4, we are keeping upwards as positive. So in this case, we are focusing on the ground and the what? And point B, which is our maximum point. So in this case, what is it that we know? We know that we've got a final velocity at B, which is 0 meters per second, because B is our maximum point. Then we've got the height of the building. So we can say V final squared is equals to VI squared plus 2G delta Y. Finally, we are at 0. Initially, we are looking for this plus 2. Our G, it's going to be negative 9,8. Then now the height of the building, now it's now what? It's now positive because it's above our starting point. So this one will be 0 equivalent to VI squared. Now as we punch our calculator, it's going to be 2 times 9,8 multiplied by 4,9. Of course, it's going to be negative 96,04. So we take everything to that side, then it means this one will be 96,04. Then we introduce a square root both sides, therefore the initial velocity. Now the square root of this one, 96,04. Then the answer here, it's 9, it's plus or minus 9,8 meters per second. So today we are interested in the one that is positive, because now we said upwards as what? Upwards as positive. So the one that is positive, finally, our initial velocity, it's going to be 9,8 meters per second. Where is it going? It's going upwards. Mind you, we are not looking for this. We are looking for the force. So in finding the force, we will apply the impulse. We will apply, of course, Newton's second law in terms of momentum. Then we are saying F net delta T equivalent to M V finally minus what? V initially. Mind you, we still said upwards as what? Upwards as positive. So in this case, the net force we don't know. The delta we are given 0,2. So then now the mass we are given 0,4. Finally, where are we finally? Finally, we are at 9,8 meters per second. So we are at 9,8 meters per second, which is our final velocity. Then initially, where are we coming from? Initially, we are coming from, where are we coming from? We are coming from 13,859. Then we divide everything by 0,2 divided by 0,2 so that we find our F net. So as we punch our calculator, let's punch our calculator. It's going to be 0,4 into what? 9,8. Whoa, the 9,8. We said upwards is positive, so this one, it must be what? It must be negative. So 9,8 bring ever to what? 13,859. Close brackets, everything divided by 0,2. So our force in this case, it's 47,318 Newton. Of course, it's supposed to be positive since we said upwards as what? Upwards as positive. So this one, it's negative there. And then let's just say, shortly, we just take the last question based on the same problem. Let's just say we choose to draw the velocity time graph. So if we choose to draw the velocity time graph, mind you, when drawing your graph, then you must have the labelings velocity time graph. So on your velocity time graph, you know that you labeled your axis, which is velocity for us, velocity in meters per second, and then we've got what? We've got time in what? In second. So initially it is dropped. So we are here, then it is dropped, then striking the ground at a certain velocity, which is negative 13, something meters per second. Then now, of course, we were not interested in the time. We can just label this one to be T1. So T1 is the time taken by the ball to strike the ground. So it is dropped. It is dropped there. Drop, striking the what? striking the ground. And then we are told that it is in contact. So this is time of contact, which is 0,2. Then it bounces off the ground. It bounces off the ground. It bounces off the ground at a certain velocity, which is now going to be what? It's now going to be positive because we set upwards as positive. So it bounces off at 9,8 and until it reaches a maximum point at what? At B. So when now you can see, this is what? This is the maximum point at B, now leaving the ground, striking the ground, and then where it is dropped. Thank you for watching. Please follow me for more. God bless you.